Space is not a smooth, continuous canvas. If you zoom in far enough, past the atom, past the proton, past the vibrating strings of theoretical physics, you hit a wall, a hard limit. Reality is pixelated. This is the Bekenstein bound, a fundamental law of quantum mechanics which dictates that any finite volume of space can only contain a finite amount of information. Think of the universe not as an oil painting, but as a digital screen. It has a resolution. And because it has a resolution, it has a limited number of possible states. The arrangement of every photon bouncing off your skin, every neuron firing in your brain, and every star burning in the galaxy is just one specific configuration of these cosmic pixels. This realization forces us to confront a number so large it creates a gravitational well in the mind. 10 to the power of 10 to the power of 70. That is the estimated number of possible quantum states for the observable universe. It is a staggering, monstrous figure, one that dwarfs the number of atoms in the cosmos. But crucially, it is not infinity. It is an integer. It ends. And this finiteness transforms our existence into a cosmic slot machine. The reals are the fundamental particles of matter. The lever is time. As the universe evolves, the reals spin, creating new combinations of matter and energy. Galaxies form, civilizations rise, stars collapse. But because the number of combinations is finite and time is theoretically infinite, the machine cannot spin unique results forever. The Poincaré Recurrence Theorem provides the mathematical rigor for this terrifying inevitability. Henri Poincaré proved that in a closed system with finite energy and finite volume, the system must eventually return to a state arbitrarily close to its initial conditions. Imagine a sealed glass box containing a gas. The molecules zip around chaotically, bouncing off the walls and each other. Over time, they disperse, seemingly at random. But if you wait long enough, truly long enough, those molecules will, by sheer chance, drift back into the exact corner they started in. They will reconstruct their original shape perfectly. Now expand that box to the size of the Hubble volume. The particles are not just gas molecules, they are the constituents of you. Thermodynamics tells us that entropy tends to increase, that order dissolves into chaos. But the recurrence theorem is a loop that strangles entropy. It implies that given sufficient time, the chaotic reshuffling of the universe will accidentally restack the deck in the precise order it holds right now. The light hitting your eyes, the thought forming in your mind, the breath in your lungs, these are not unique events. They are coordinates on a closed track. We are not moving forward into a new future. We are cycling through a predetermined playlist of quantum states that has no choice but to repeat. The slot machine hits the jackpot not once, but infinite times. History does not just rhyme. It is a carbon copy, etched into the mathematics of a finite reality.
From that paradox of finite states, we encounter the destroyer of cycles, dark energy. The universe is expanding, and it is accelerating. If space grows forever, the walls of our cosmic box fall away. The gas particles disperse into a void so cold and vast that they should never meet again. This is the heat death, the era where entropy maxes out and time becomes meaningless because nothing ever changes. Conventional thermodynamics suggests this is the final grave of reality. But quantum mechanics refuses to let the universe die so easily. It introduces a mechanism of resurrection that operates in the deepest silence of eternity, quantum tunneling. Even in a vacuum completely void of matter, the quantum fields that underpin reality never stop fluctuating. They jitter, they boil. In a de Sitter vacuum, the empty, expanding state of the far future, these fluctuations are rare, but they are non-zero. Given an infinite timeline, even the most improbable event becomes a certainty. This leads us to the double exponential. The time required for a random quantum fluctuation to spontaneously assemble a new Big Bang, or even a fully formed brain out of the void, is calculated as 10 to the power of 10 to the power of 56 years. This timescale is so vast that writing it out would require more zeros than there are particles in the known universe. Yet on this timescale, the heat death is not a graveyard, it is a waiting room. The chaotic thermal bath of the dead universe will eventually, inevitably, fluctuate into a state of low entropy. It will jumpstart the heart of the cosmos. This aligns with Roger Penrose's conformal cyclical cosmology, which suggests that the heat death of one aeon is merely the Big Bang of the next. The geometry of the infinite future maps perfectly onto the geometry of the singular past. The scale dissolves, and the universe forgets how big it is, resetting the clock. This means the particles that compose you are not lost to the void. They are merely on hiatus. When the recurrence time elapses, the dice will roll the exact combination that defines your consciousness. You will not remember the trillions of years of darkness. You will simply blink and be here again, reading these words, feeling this existential weight. The you that exists now is just the current iteration in an infinite series of identical selves, trapped in a narrative that cannot end because the laws of physics demand that the impossible eventually happens. We are not traveling a straight line from birth to death. We are walking the circumference of a circle so huge it looks like a straight line, unaware that our footsteps are falling into the tracks we left an eternity ago.